Is it okay?
Yes, sir. Now
Yes,
it
sir,
is okay.
started.
Yes, sir. Yes, sir. Now it has started.
Okay. So, case one is this one, and we have already worked on this part. When there is an intersection, how to find the shock. There is a shock. These type of solutions are called shock waves or shock solutions. We have found what's called show the f of u r minus f of ul upon u r minus ul. Okay, so they basically we want to know with what speed the shock prop. This is nothing but if you have the parametric form of the this is the parametric form of the uh, curve along which its discontinuity propagates. Okay, this is our equation. You saw when we solve, we get x is equal to psi t, which is the parametric form of the curve along which the shock propagates, and we have derived how it, and yeah, um, this is the case one. Now coming to case two, that is consider the simple example. Instead of earlier we have considered 1 and 0. Now consider this is 0 and this is 1. That is ul is this is our hx. Ul is 0 and ur is 1. Okay. So the case is this is ur. This is ur. So ul is smaller than ur. Okay. What happened? What are the characteristics in this case? In this case, we have ul is equal to 0. So how to draw the characteristic curves? Where this so this is our hx. This is our hx. So for the budget, ux plus uy is equal to 0. So write characteristic equations. Dx by dt is equal to d is t sorry d is c, that is 0. Okay, this is equations and solve them. This will as t is equal to hs part, and this we'll get is y is equal to t, and this we'll get hs. So now substitute hs. So x is equal to, what is hs when x is negative? When s is negative, this is hs is equal to 0. So this is s. When s is positive, so it is characteristics. This is x, y, or s and t. S. Um, x is less for a less than 0. It is just x is equal to s is the line. So x is equal to s lines. And when S is positive, any positive S, what is this line is X is equal to T line. Okay, X is equal to T line.
So we can't
So
see
for
anything
any
on the
S
screen.
positive, you can't see anything on the screen.
Yeah. Now it's visible. Now it's visible. There were certain
Okay.
lagging issues.
Okay, lagging is there. X is equal to T, and suppose this is 1, then it is a T plus yeah. So what intercept, and this is same slope. Slope is lines parallel to these. So now we can define the solution u is equal to 0 on these characteristics. For any given s, you can draw, take as u is equal to 0. Here, u is equal to 1. So now what is the condition here? There are no characteristic lines. So how to define, there is no information, there is no characteristic line. So we cannot, how to go about defining a solution in this wedge. Okay, that is between 0 and between x is equal to 0 and x is equal to t. So when x belongs to 0 and t, how to define a solution? Okay. So this is in this case we want a continuous solution that is. So let us say that okay, why not we do considering there is a shock, and how we can also define something like t by 2, take a trade-off x is equal to t by 2, and left hand side of the shock take these, and right hand side take these lines, draw the characteristics as this. One can say the find the xi prime t. In this case also the same thing, f of u r minus f of ul upon ur minus. So here what is ur, f of so this is nothing but ur plus ul in this case, because our f of u is u square by 2. So in this case it is ul. So what this is equal to ur plus ul is 1, right? Yeah, right side value is 1 and left side value is 0. So this is xi prime t. Integrating, get xi t is equal to t. Is it correct? No, the u square upon 2. This is u square upon 2. Yeah. Okay. So this is half. This is half t by 2 plus constant. This is x. So put t. We have problem at t is equal to 0 only. So constant is 0. So take. We can say that draw the line t is equal to 2x line. T is equal to 2x. This is equal to t is equal to x line. This is t is equal to 2x line. This is x and this is t. So one can say that okay, you have the characteristics, draw the characteristics like in the left hand side of t is equal to 2x line, draw these characteristics, and in the right hand side draw these characteristics, and we have this. Okay, so fill the wedge shaped region, wedge with these characteristics. Take here u is equal to 0, one can say that. Is this solution? Is this solution? This is one way of defining the solution. Is this solution physically acceptable? So that is the we need some more condition. Physically acceptable solution, physically relevant. Okay, so there is a theory which says that this will not be acceptable, but we should have a solution which is continuous. This is not. We need a continuous solution or a wave type of solution. We'll explain everything why this is not acceptable and why we need to the solution which are going to define is a continuous solution. All that we will discuss now. So for that, we have earlier also looked at something called similarity solutions, or if there are two variables x and t, there is something called if you is solution, that is the making it a single. If when there are two variables, is a function of by putting t. Okay, so we are defining a new which is x of will this be function a solution? This is called similarity type of solutions. We looked at in this very common way of defining a solution. So for t is positive, then only we can divide by 20. This now in the, our equation ut plus g of u at x is equal to So what is the first step now? Now substitute this. What is gu at x? This is equal to g of. Now substitute the v of t x upon t. Okay, with respect to x. What is this? Is like a chain rule. There is a function g also. There is a function v also. So it is g prime of v of x by y. We are treating this as a single variable. So g prime of this into v prime of x by x by t, x by t, x by t. And what is the derivative with respect to x? That is 1 by t. Okay, 1 by. So what is this dash? This prime? This prime denotes the derivative with respect to the variable. We are considering this as a single variable now. Variable xi, which is x upon. Okay, prime is a derivative with respect to xi. So now what is ut? Ut is equal to v of x upon t with respect to t. So this is equal to v prime into derivative of the thing inside with respect to t, that is minus x upon t. Okay. Now substitute these things. Substitute these things in the equation. G of u x plus ut is equal to 0. Okay. Substitute this here. What is the thing? Here it is this one. G prime of v of x upon t into v upon x upon into 1 upon t plus or minus x v prime at x upon t upon t square is equal to 0. And of course, v prime is not 0. We don't want just a constant function. We want a non-trivial function. So v prime is not equal to 0 because v is non-constant. So we can cancel out v prime upon x upon t. And what we have now is take the 1 by t, t is also positive, so cancel t also. So now we have g prime of x upon t is equal to x upon t. Okay. So from this, what we can conclude is that this is g prime of x upon t is equal to e of x upon. So how to define this new v is define v of the similarity solution of x upon t is equal to whatever is our flux function. It is its derivative inverse at x upon. Okay. Okay. Take as this. So what is in our case? In our case, we are dealing with Burger's equation. For example, in Burger's equation, what is our g of u? G of u is u square upon 2. So in this case, what is g prime of u? G prime is just u. What is g prime inverse? Okay, it is just identity. G prime of u is identity function. Identity function. So v of xt. So inverse will be just v of xt is just v of xt is g prime inverse of x by t. So, but g prime is this is just x prime t, x upon t. Okay. So this is the way we can define. Now come back to our x and t. So we have characteristics like this. We have characteristics like this. So in this region, take for t define the solution as x upon t. For any point here, for any point xt here, draw the line x upon t. So these are the lines. Okay. So this is the way we can define this is continuous solution. Continuous solution, and also these are called these are also called simple wave solution or rarefaction expansion fans. This is like a fan solution, right? This is like a fan solution. Expansion fan. And now this theory of simple wave solutions can be applied any g which is smooth function, even g of u is equal to or 4 upon 4, like that. Any examples can be solved using this way of defining the okay. And we'll yeah you also refer to this all materials in the home page, in our home page, in the course home page. Towards the end, I have placed notes of conservation loss. I don't have to send it through Moodle, but you please see the in the course home page. There is notes on conservation loss. First notes is by TIFR Professor, and one more professor, Judith, that is Professor Siddharth Mishra. I know this McCowan is a little very precisely written, so have the by TIFR Professor and Professor Siddharth Mishra. Okay. These are the reference materials for understanding these type of expansion fans and rarefaction waves and shock solutions also. Okay, please study the things from these notes also. So now we have exercise sheets. Exercise sheets. So we have solved the problems. There are several examples given. So from the next class, we will first finish the sheet 1 and 2. We have to finish and 2 exercise sheets. So we will discuss one by one problems from each sheet. Okay. And after that, after finishing these 2 sheets, we will go to the general nonlinear PDE, first PDE. Up to now, we looked at like linear, semi-linear, and quasi-linear. Okay. So what is general nonlinear of like x, y, z? Z is u and ux and u is equal to 0. So ux we call it as p, and this we call it as q. So this is f is a function of x, y, u, p, q is equal to 0. So this type of equation. So any like ux into uy is equal to 0. For examples, ux into that is pq is equal to uy is equal to then uh, yeah. The other way. And ux, oh, sorry, ux uy is equal to u is another example. And so on. So what is the now here also we will have a method of characteristics, method of characteristics. So here what are the characteristic equations? So we'll have, instead of 3 equations, we'll have 5 characteristic equations: dx by dt, dy by dt, dz by dt, dp by dt, and dq by dt. Okay. So what are these? So these are the how to obtain these. So dx by dy by dt is equal to p, and dz by dt is equal to p. Uh, TFP plus QFQ. Okay. And dP by dt is equal to minus Fx minus Fz into P, and d upon dt is minus Fx, dq upon dt is minus Fy minus Fz. So how to obtain these 5 characteristic equations? First of all, why 5 characteristic equations? Why we have to obtain 5 characteristic equations? And what is the so there is a x variable, so there is x variable, there is y variable, there is z variable, there is variable, and q. So x s1 like that, s2, and like we have h of, sorry, s and d are enough. S and d, h, s, yes, and okay. This is our gamma. So with these 5 system of ODEs, and with these 5 initial conditions, we will solve the use we will solve for and we'll obtain solutions for this non-linear equation. So why we need, how to obtain these equations, and why we need 5 equations, how to get these 5s and psi s, all these will be discussed in detail. This is all theory. After this theory, we will work after solving the sheets, exercise sheets 1 and 10. And after this, completing all these, we will have minor test 1. So please start working on these things. Minor test 1, I am in advance announcing. So since we have majority decided to have 4 tests, each of 25 marks, so we'll have minor test 1. Date we will decide. Minor test 1. Syllabus I am telling. Syllabus is this first order PDs. That is linear, semi-linear, quasi-linear, and fully non-linear. Okay, all these 4 types. Okay, that is the syllabus that in one. So this plus sheets 1, 2, 3 exercise sheets. Sheets 1. This is the syllabus for minor test 1, 25 marks. Okay. So so if you get 1, 2, 3 problems are theoretical. The method of characteristics. Okay. 4 is just 4. There are 3 parts. A, B, C. Okay. The 3 problems in the next class. You go solve the solution. So please go through the solutions for 4th problem A, B, C. Next we have initial value problems, solving by method of characteristics. Okay. Even the solutions are provided. And 5th and 6th. Okay. 7th problem is 5th and 6th are also same. You try to finish the 4, 5, 6. 7th is by Lagrange method. That is just the equation is given, PD is given, no initial condition. No initial condition. So just PD is given. So this is called by Lagrange method. Find the general solution. So again here there is something called general solution. For initial value problems, it is a particular solution satisfies clockwise particular solution or integral surfaces. Okay, and what is the third variety? General solution, integral surface, and yeah, yeah. The integral surfaces and general solutions. Okay, if the initial value is not given, we call it as general solution. If the initial value is given, then we call it as integral surface equation. Okay, so 7 is 7, 8. Yeah, 7, 8 is of this type. 7 and 8 are general solutions by method of Lagrange. So I will do these problems 7 and 8 in the class. Next is 9. Yeah. Ninth is also a different type of problem. We'll do it. Please, you work out on 4, 5. These are road formula based, so you please work out on problems. In the next class, I will solve 1, 2, and 3, and also go to 7, introduce Lagrange method 7 and 8 and 9. Okay. So I'll stop here today. So if you have any doubts, you can ask. So we'll leave the class. Nobody is responding. Yeah, I'll stop here.